Hey, so here is the badge for functions, level 1, and I want to take some time to try to explain what a function is and how to do them in Python. Functions are kind of a new way of thinking about code than what we've done so far. It's kind of a new um, model of coding that we haven't really done, and so some people get to functions and they get a little bit confused. Um, but it's not too bad. There's just some basic things that I want to make sure that you understand going into them. So, the way to think about a function is thinking about kind of a black box that just solves problems for us. So, if we have some code and we have a problem in our code that we want to solve, imagine that we could send that problem out to a black box. That black box does some work, some calculations in the background that we don't really know, and then it sends back to the code the answer to that problem. So we don't know what happened over here, but some function took care of the problem and we got the answer back. Now obviously when we're coding our own functions, we do know what the how it solved the problem, but sometimes we use functions from other people. So let's talk a little bit about some of the benefits we have with functions. The first one is organization. If we um, build a program where we mostly use functions to do all of our processing, then each piece, like every kind of mini problem we have to solve in one problem, we can do in pieces. And every function will have its own solution. And so every little piece gets its own solution. And then when you need to work on one part of a solution or another part of a solution, it's pretty easy to do because it stays organized for you. In some ways, you can think about that as each function has a little algorithm that it needs to work on that's kind of separate and independent from the rest of the program. The second thing is repeatability. If this is a problem we're going to have over and over again, once you create a function to solve that problem, it's done, and you just have to tell it to go run that function. So functions can be reused. This is really handy if you're able to export that function and bring it into a whole nother program. Then every time that you need it, so you can think about this as like a company that does code, and once they solve something that they need to do, they can kind of do it over and over again and not have to reinvent the wheel every time. And the third thing is this idea of abstraction, and that's kind of the black box idea. We don't care how the function gets its answer. We don't need to know the algorithm inside that function. All we need to know is what do we need to do to get the function to work, and what kind of information might the function send back to us to tell us what the answer is. We've used functions already in this class. Anything with parentheses in it is basically a function. So you can think of the print statement. We don't know how Python actually ends up getting that information from from our code to showing up in the console. That's the black box idea. But it does, right? So we don't need to know the code that they use for the print statement or the input statement. Or we've used other ones like converting, information to an integer or printing out a character of Unicode. Every time we had one of those pieces with parentheses in it, it's been a function, and they work even though we don't know exactly what they're doing. So, in your code, if you need to make a new function, you do that with this idea of defining a function. So, you'd say def, and you'd give it a function name. That would be just like a variable name, it can't have spaces and things like that. And then a function gets parentheses behind it. So that's kind of what separates it from a variable, is it has these parentheses. And then we'll get the colons, and then all the information, and I'll show you an example in a minute, but all the information would be indented And that would be like, oh, this is the stuff that is in the function. It's indented from inside of it. Then there's one piece that I didn't put in there, and that's the inside the parentheses, you might have some parameters. This is information that the function says, if you want me to solve this problem, you have to give me some information. The function will just say when that information comes in, I'll call it maybe an x or a y, right? These are like just variable names, basically. These are variables that the function says I need these variables in order to function as a function, in order to solve the problem you want me to solve. So let's just say that the problem is to solve the area of a trapezoid. What do you need to know in order to do the area of a trapezoid? You need to know, like, is it just the length and the width, or the two lengths, I guess, the top and the bottom length, and then the side lengths? Yeah, I'm not looking up the definition, how to do that, but you can imagine there's information you need to solve the problem. You can't just solve it, abstractly. So those are called parameters. And we'll be using those. You just kind of need to understand them. You also have to understand that they have a particular data type. If your function works to solve some sort of text problem, you can't send it integers. Or if it's supposed to solve integers, you can't send it text. So another to use that area of a trapezoid example, you can't send it like a string of your favorite cookies and expect it to solve the area of a trapezoid. So here's how a simple function would look. So it's a function called greet. So it's defined and it says I expect there to be a name. Now we don't know, what that name means, but obviously if you look here, it expects it to be text, right? So it's like a string function. And then what will it do when you tell it to do this function? It just will say print good morning, the person's name, how are you today? So this is quite a simplistic example, of course, because why would you write a function that just does this all the time? You could just print it just as easily somewhere else, right? But imagine that there was maybe a menu of information that you might want to give, and you don't want to print the menu over and over again, but the user may want to see it over and over again. So you could put that in a function, or instructions to a game, or later on we'll be creating like a little text adventure, and maybe you would want to give them a map, and you don't want to print that map out every time that they want to see it, so you make a function and it does it once. Then like I said earlier, the functions can return like an answer. Not every function does. The function that we just looked at, this doesn't have anything to return. It does what it was supposed to do, and then it's done. But sometimes, you're asking the function, if I'm saying the area of a trapezoid again, I need to know the answer to that. I don't want it to just take that information and then disappear with it. So, in order to get the information, you have to have this return. This means go back to where you came from and give it the answer. Now, this function, I just kind of created it and I haven't even tested it, but the idea is if you've done the string badge, that you can take, you can send it a string, which it will call X, and it will do this code and find the first half of that string. So if you send the string, I don't know, let's see, what's a four-letter word like baby, then it should send back ba. So what it does is it finds the length of the string. If that length is even, it divides it in half. But if it's not even, it first adds 1 to it and divides it in half. And then it finds the first half of that string and it sends it back to the function that asked for it. So, you could imagine, maybe I don't want to do this over and over again, but I did want to divide some strings in half for some reason. So now I have a function that can do it. The important thing here is just the obvious one. If a function is supposed to give you an answer, then you want it to give you an answer. By the way, this is supposed to line up here, but this font doesn't line up well, just so you know. So how do you tell a function to run? Like so far we've defined the function, so now there's a function out there. Well, the way that you tell a function to run is that you just tell it to do it. So you just say, hey, I want to greet this name. And it goes and it finds where you define that function, and it does what it tells it to do. So this would then, go do the example from earlier. So that could be anywhere in your code. You could just say, okay, I want to go do that. You could even do this with inside another function. Say, hey, I want to, in the middle of this other function, I want to go, greet this person. So that it's really easy to call a function. When the function's done, it gets done doing what it's supposed to do, and then it comes back and continues with the code. So it's almost just like a shortcut. Excuse me. If the function returns information, that information has to go somewhere. You have to do something with it. So you might want it to equal something. So here it would be running some code, and then it says, hey, I need a problem to equal half of the string, and I want you to do half of somebody's name. And then when it returns, now example equals the results of that. So again, to take an area of a trapezoid or something like that, you might say area equals, trapezoid area, parentheses, the height and width or whatever we need to send it. And then when it comes back, the answer will go into the variable area. You could also just maybe print the answer. Maybe you don't need to send it in a variable, but you want to do something with it. And that's the information I want to tell you about a function. Now, let's take a quick look at idle and kind of show you how that works. So here I go. See, there's that def. So there might be how I write it. Now, the first thing that I'll tell you is that you want to write your functions first. They're like the first thing that goes into your code. So I'll show you why in just a minute. I'm just going to make this even more simple than I did before. But just imagine some print statements here. So when I'm done with my function, I stop indenting. Now down here, this might be the name of my function. This might just be some stuff. So there I was, talking to Joe. And then you could say greet, and I want to send it the word Joe. And so when I run this, so there I was talking to Joe. Hello, Joe. And so, this I put way up here, but it doesn't do it until it gets called down here. So I called the function. So now we can actually do things out of order kind of in our code, right? Because normally code goes from top to bottom. What happens technically is that it kind of stores, oh, there's this thing that you want to do called greet. So I'm going to store that in my memory. And then as soon as you say down here, I want to greet, then it's like, I remember that. It was in my memory. And that's why you have to put functions on the top. Because if I do this, it might work. Some languages let you get away with it and some don't. So let's see what happens. But, we say greet, and so far in its memory, it's going to say, yeah, I don't know what greet means. Greet's not a word I recognize. And then down here, oh, I recognize it, but it's too late because here it's going to have a problem. So let's see if I'm right. Yeah, I'm right. See, it's like greet is not defined. So what do I do? So your functions always want to be the first things in your code. This can get a little confusing if you have a whole bunch of functions because, let's just imagine that we have so many functions that our main program that we actually want to run doesn't even show up on our screen for a while, and you can kind of lose track of where your program is because you've got all these functions going on over here. So that can be a little crazy. I find that it might be really handy to put some comments. You might even call this part of it the main function, like the thing that runs first. And that's how a lot of programming languages think about functions, is that everything has a function. Even the right main computer, I mean, like the main code is a function. It's just the one that runs right away. And then what you do is you think to yourself, the main code you want to be as small as possible. You just want it to run functions and let the functions do all the work. That's kind of a whole way of coding once you really get into functions. So I also sometimes even put comments here just so I can find them easier, but obviously right here it's just a few simple functions, so you're like, well, that doesn't seem that hard to find. But imagine that these functions were long and kind of did a lot of things. You may want to make comments so you can kind of find them easily. So that's how functions work. Well, let's just do one more. Let's just say that for some reason, after we greeted Joe, we wanted to return something like a string that wants to send information back again. So down here, I would have to say something like um, response equals greet Joe. Now that's weird, but basically what I'm saying is this greet Joe has an answer to it. And it's, Joe says hi. And then down here, we want the response to equal that. So if I run that, nothing's going to happen. Well, okay, first of all, it's crabby that I made this function called function1 and didn't put anything in it. So I'm just going to quick put the word pass in there. That just means ignore this. There's something there. You can't have nothing there. So this is just kind of like a pass. It just says, well, something's there eventually. Don't worry about it. So I run that and it says, hello, Joe. Now it never said Joe says hi because, hey, it equals response, but I never printed response. So now I could say print response. And then it should say down there, tell me that Joe says hi. So that's how functions work. Functions can get really complicated. This one is a simple example, but they're so powerful. They're really cool. And there is one last confusing trick, which I'll deal with in a separate area, that you don't really need to know about in order to get started in functions. Eventually, it'll cause some problems, so I'll explain that one somewhere else. But for now, I think you can get started using functions. Good luck.